Okay, let's talk about our second objective. We just talked about the CPU. Now, directly related to the CPU is the chipset. Now, the chipset, as we know from Chapter 1, controls the flow of information around the motherboard back to the CPU. And so it therefore also controls what components are usable and work, because if it can't talk to it right, if it can't control the flow of information to the CPU right, computer won't boot, or it'll blue screen. All in all, it'll be bad, right? So we need to understand a little bit about the chipset. Number one, we have no choice, right? When we buy a motherboard, it lists right on the motherboard specs what the chipset is, and it is what it is. We can do research on chipsets, mainly just knowing that the chipset controls, it controls what CPUs will work in the socket. Just because it fits, if the chipset can't talk to it, it won't work. And it controls all the different kind of things that also communicate with the motherboard. Through the motherboard with the CPU. So it controls all of these things, all the things that are connected to and talk through the motherboard to the CPU are controlled. That flow of information is controlled by the chipset. We said before in Chapter 1 that the CPU does the majority of the calculations on the motherboard. The sockets do that small amount. And this arrow right here, you can see the north bridge pointed to the north bridge right there. And if you could read this one, this is the south bridge. As we said before, when we look at a motherboard, we should be able to identify the chipset. We know this is an LGA because of that hook and the cover on there. This one has never had a CPU, and that's a plastic cover over the metal cover. The biggest heatsink on the motherboard after what we see over the CPU is always the north bridge, because it controls the fastest information that's getting to the CPU, and it's usually closest to the CPU. And then the next one is a south bridge, which is the next biggest heatsink on the motherboard and controls the flow of all other information to the CPU. So as we look at this one, we can see there's the CPU, there's the north bridge right there, and the south bridge is really small on this one. It's an older motherboard. There's the chipset. I think that's the south bridge on this particular motherboard. Now, when we go to the specs, and this is a blow up of a Newegg page of a particular PC, it says on there, the first thing that we've already talked about, it says the supported CPU. It says the socket that's on that particular motherboard. This is an LGA 1200 socket. And it says what CPUs of 1200 LGA sockets that it supports. So this one in particular supports 10th generation, so only 10th, because I'm listing the other ones, 10th generation Intel Core, Intel Pentium Golds, and Intel Celeron processors. But down here, we can see it lists the chipset. And this chipset, the Z490 chipset, then controls all the flow of information that goes to that computer. So when I'm just going to pop up this one. This is the Asus motherboard, and Asus is the manufacturer of the motherboard that uses the socket Intel, that only Intel CPUs go in. And when we go down to the specifications down here, that's where we see those things that we just pointed out. The supported CPU, the chipset, what kind of onboard video, if any. And this is the next kind of most important thing that we're going to talk about, is what kind of memory specifications that this particular motherboard and chipset can handle the communications between the two. And it's important that you understand that it's all about whether it can talk correctly with the CPU, because physically, DDR4 is all physically the same. A DDR4 memory will fit in any DDR4 motherboard, but if the motherboard can't talk to it right, if it can't transfer the data from it right, that computer will never run stable. So those are the things that we can look at when we look at the motherboard, and it says all these different things. It says both the physical characteristics of the motherboard, but it also talks about within that physical characteristic of SATA, then what SATA works in it. So those things are all determined by the chipset of the motherboard. So the chipset not only controls the flow of information to the CPU, it controls all the list of things that can talk to the CPU. It's part of the form factor of the motherboard. And I just said this, for example, all DDR4 memory fits into all DDR4 memory slots, but that doesn't mean the chipset can handle all the different speeds of DDR4. That's part of the form factor, the build of the motherboard itself. And both the BIOS and the chipset have to be compatible with the architecture of any hardware component that we add to it. So, chipset controls memory cache. That's where the memory goes as it's coming in and out of RAM. It controls the information to all the external buses. It's the interconnection between everything that's plugged in to this motherboard and this CPU. And we've already said down here, the North Bridge is the fastest one, gets the hottest because it's for graphics and memory, and the South Bridge or the South chipset is for everything else on the motherboard. So just another picture showing that the chipset controls the flow of information to and from the CPU. The chipsets go through the North Bridge, that you can see RAM and video talk through the North Bridge to the CPU, and all the other things go through the South Bridge to the CPU. Picture of a bus showing that the bus that's the north route only has 2 players, memory and video. And I know it sounds like I've said that a whole lot of times. It's definitely going to be on a test. Multiple questions on a test, because it's important you understand. That's why the North chipset gets so much hotter. The South chipset, or the South route, makes lots of stops. It takes a lot longer for information to get to the CPU because there's less of it. The information coming in on your mouse, as I move my mouse, is far less than the thousands of times that memory is accessed in a single second, right? We know memory on this particular computer, for instance, goes 2.4 gigahertz memory, so 2,400 million times a second, or 2.4 billion times a second, it's being read and written on the motherboard, right? So it's really, really fast. Yeah. And this is another picture showing that it's a bad graphic in that it's not that linear, but those are the things that can be on the North route, and those are the things, along with everything else that's not memory or video, that can be on the South route. And this is just a picture showing there's the CPU, there's the memory, and this big heatsink here on this particular gaming motherboard is where the North Bridge is. The South Bridge is a relatively large heatsink on this one as well. And this one's much smaller. We've already looked at this motherboard to show the different sizes, and that's really related to the ability of the motherboard to handle that traffic and what you want it to be able to do. So that is the chipset in a nutshell.